Yes, guys, today's topic is friction anomaly. What is friction anomaly? Generally, it's a misconception that friction is always a bad, I mean, negative work or negative outcome, but it has dual nature. That is, it exhibits positive and negative output. Let us see how actually it is positive and how actually it is negative. First, let us start with an example. Let us say an object is there on a surface. Let us see an example. Let us say an object is there on a surface. Let's say we call it A and we applied force F and we want to move A. Now what will happen due to the friction here? That friction will resist the body to move in this direction. So ultimately what happens, this is the force you apply and this is the friction force that that acts due to friction. So here friction is restricting your force, your desired output is to move object A, but what is happening, friction is restricting A to move in this direction. So let us say another example where an object A is there and an object B is there. Now you applied force on this object, but your desired outcome is to move A. It's your desired one. So what should you do? You have to increase the friction here. So what happens? So on B, if you apply force F, the friction will act like this, and on A, the friction will act like this. So again, the friction is acting. Let us say it is F1, otherwise FAB. Let us say FAB. So FAB will act in this direction, but there is friction here too. So let us say this is FA. So if FAB is greater than FA, then A is also moving because FAB is greater than FA. So A will start move. So here your desired outcome is to move A, and the net result here is A moving. But why is it happening? Due to the excessive friction between B and A. So here friction is helping you. Here it is doing positive work. Here it is doing negative work. So friction is not always a villain. It acts like hero sometimes. Let us go with another example. Let us see. Let us say a ball is moving with angular velocity omega. Now let us say here friction exists. So what is the net force? Net force is this one. That is that has, let's say this has torque tau. So this F is equals to tau by R if radius is R. So here the net force is F, and due to the friction exhibits a force like this. Here friction is restricting rotation. Let us see another case. Let us say this is friction. There is friction on the surface. Now you just applied a force called P. Now what will happen? Because you are applying force in this direction, the friction will be here like this. But what is happening? It forms a couple P F, and it will result in rotational motion like this. As it is a couple, you will get a momentum, net momentum in this direction. So this body starts moving in this direction. So here friction is responsible for this body to rotate. So here it is doing positive work, Here it is doing negative. I would say friction is one of the best gift given to the humans by nature. Let us say another example. You might always, I mean, everyone might have seen this setup. A shaft will be there. This is a motor, and it is connected to a belt, and which, I mean, it is responsible to transmit the rotational energy that is gaining from shaft to the desired output. So how is it happening? Due to the friction between belt and shaft, it is transmitting energy. Otherwise, if friction is very less, if friction does not exist, the shaft will keep on rotating and slip occurs and belt doesn't move. So transmission of energy might not possible without friction. So this is a case with ropes also. So conclusion: friction acts as good work as well as bad work. So that's it for today. Presentation that we just discussed will be kept in the description. I mean, you can follow the link and you'll get it. This channel is mainly intended to provide quality questions that are generally asked in mechanical engineering interviews. So, I mean, to get more of this content, follow this space. Goodbye.